Hi everyone, I'm David Rouquet from the French company Tetras Libre, and I'm here to present the Mirador multi-user workspace. So, a bit of context. Mirador multi-user was first co-financed by Rennes 2 University under the brand Harvest. They hosted a workshop during the last IIIF conference, and we are the original developers and are maintaining active forks of this project on GitHub. And we have contributors from Leipzig University and École des Ponts in France. So an overview of what the Mirador multi-user platform is. So it's built around the Mirador IIIF viewer, and it allows to upload some media content on the platform and create some IIIF manifests from those content. Then there are annotation features that you can use in collaboration with other users on the platform. Without further ado, let's dive in the real demo. So first I will log in to my personal workspace in the platform. On the bottom left, I have my settings, including an API token in case I have to interact programmatically with the platform. I can manage group of users to ease the sharing of my contents. And here I can add members and define the rights of the users. Then I have a media library where I can either link some medias already uploaded on the internet or upload them from my computer. We support different types of media like videos, images, and files. And if I edit my media, I can choose whom I'm sharing it with. So it can be individual users or groups that I defined. And for each share, I can define the permissions that they have. So from those media, I can create manifests. So either link existing manifests, upload them from my computer, or create them directly on the platform. So in order to create the manifest, I need to access my media, and I can do it from a dedicated tray that is on the right at all time on the right of the screen. If I forgot to upload some media, I can do it from here on the fly, and it's added to my library. So let's create a new manifest with a new canvas. Simple manifest, and if I create it, okay, it's added to my library. So when I edit the manifest, I see that I can share it with others. Oh, I forgot. You can also, for all the content, edit the metadata of the content. By default, we use Dublin Core. You have here all the Dublin Core fields with their descriptions. But you also can upload your own metadata scheme. There is also an advanced edit mode where I have direct access to the manifest code. That is very useful for advanced users or for debugging. So then, from my manifests, I can create some annotation projects. And here in my project, besides editing the sharing, the metadata, I can also define annotation templates for my projects. And a template will be kind of an annotation guideline for my annotators, so they know where to start with, and we can achieve a more consistent set of annotations. So you can have several of them, and depending on the content that the people are annotating, they can choose one or another. Also, you can add tags, predefined tags to your project, so the annotators will find them readily available and they will not recreate their own tags So again, it's better for the consistency of the annotations. I can also define snapshots of my projects. So those are public links that can be shared so people can see the project in read-only mode. So let's open a project and annotate it. So this is a video project. And here I already have a bunch of annotations made. If I double click, I go directly to where the annotation starts. Here I see that I can have drawing overlays over my images or videos. I can also annotate the video with another manifest, and I can readily open the manifest in my Mirador workspace. So manifests can cross-reference themselves in annotations, or I can have simple image annotations. So let's create a new one to see how it looks like. So you have different type of annotation you can do. So we already went through a couple. And I can also add a note annotation. And here I can choose the template I want to use. Okay. So I have my annotation guidelines. Let me define some target for this. I can also define, okay, the time range for my annotation and some tags here. So with the predefined tags that are available. So let's save it, and we will see it. We will see it appear here on the left. All my annotations on the left are I can filter them by free text search or by tag, and yeah, this is what I can do with this platform. So you can find us on GitHub or with a software as a service platform that is readily available. We have free plans, not limited in time, so please don't hesitate to join us and test a bit the platform. Thanks for your attention.
Okay, I'll hold it for a second for people who want to grab that QR code. Okay. Up next, we have a presentation from Allison Sherrick.
Hello, everyone. I am Allison Sherrick, Digital Projects and Services Manager at the Metropolitan New York Library Council based in New York City. Today, I will be discussing the customizing of Mirador settings in Archipelago Commons, the open source repository platform that is developed and supported by the digital services team at Metro. Mirador is one of the most popular IIIF viewers used in repository systems around the world, including Archipelago. Within Archipelago, repository managers are able to take advantage of the adjustable settings provided by Mirador's codebase, which shown on the screen here, and also take advantage of Archipelago's specific integration documented here in order to easily customize default display setups for Mirador. I am now going to walk through a brief overview of these specific JavaScript settings that Mirador permits to be customized or overridden in the default settings.js configuration file in one of our partner Archipelago sites, specifically that for Barnard College and their alumni scrapbooks special collection. So right now I am logged in as an admin user for this site, and I am looking at this Jessie May Wendover scrapbook object, and you can see that the default Mirador viewer here is very pared down, very slim compared to the standard default settings, with most of the default Mirador buttons and panel items hidden. I'm now going to select the Manage Display link to hop into the display mode configuration area of Archipelago. I am going to open the Digital Object Creative Work Series Scrapbook with Mirador Viewer section. I'm going to scroll down here and navigate to the Strawberry Field Formatter using the Mirador IIIF Viewer plugin section. And I'm going to open up this cogwheel on the far right-hand side. I'm going to scroll down a little bit to make this easier to see. In these particular configuration settings, first that we're using Mirador for, and that this viewer is the source for the IIIF manifest URLs is generated by a metadata display template. That's a topic for another time, but that's just how it works in Archipelago. That's all you need to know for today. Okay, so you can see that in this section here of the advanced JSON with Mirador viewer configuration overrides, you can see that this section contains some of those overrides. We provide a link directly out to the Mirador settings mentioned earlier, and I just want to note here that you should scroll down to section 464 to follow along with the settings here that are most relevant. Reviewing these details in the Archipelago example, I'm only going to mention the settings that differ from the default Mirador settings. So you can see that the team at Barnard College chose to disable the option permitting closing all windows. They enabled the full screen button to allow full screen. They disabled the ability to let windows be maximized. And they set the sidebar search or sidebar panel to default open to search. Related to that, under panels, they chose to have only the canvas, search, and layers be available, no info or annotations. You're going to see a different example that does include those panels, subpanels, later on in the presentation. And then scrolling down just a little bit, you can also see that they chose to set allow new windows to false. Okay, returning to the scrapbook display again, just want to note that this is very minimal. There's no metadata from the record presented here. It is really just intended to bring you directly into the material and provide a way to search. So here I'm searching, and yeah, that's just an example of the display. For comparison's sake, I'm now going to hop over to the Digital Culture of Metropolitan New York Archipelago site and quickly show those additional panels enabled where you can see some more metadata from the object record is being pulled in, and there's just a lot more going on, even with such the small addition of some panels and a few more of the available Mirador buttons and settings. All right, that wraps up for today. Hopefully this brief presentation enabled you to see how, depending on your institutional preferences or the particular special collections materials that you're working with in your own repository, you may want to choose different adjustments, play around with some of those options for the readily customizable Mirador settings, and how doing so can help you work towards some modifications that best fit your display or interaction needs. Thank you for your time and attention during this lightning talk. Thank you also to the development team at Mirador for providing the many different configurable settings for Mirador, and to IIIF staff for providing presentation space during this IIIF online meeting. Please feel free to follow up with me now during the live conference or anytime afterwards with myself and my colleague at Metro, Diego Pino, if you have any questions about Archipelago's Mirador display customization options or any other Archipelago related questions. Thank you.
Great, thanks, Allison. Up next, a presentation from John Moore.
Hello everyone, I'm John Moore from the National Archives in the UK. I'm going to present Tamerlane IIIF Viewer, a focus on searching collections. Tamerlane is a IIIF viewer supporting presentation 3.0. It's able to search annotations at collection level, and we'll give 3 examples of this. Digital Doomsday is a collection where each manifest maps to a chapter of the book. The annotation content has come from research projects, so it's transcriptions of the book. We will show a cookbook recipe of a newspaper, which is a simple example of a collection representing OCR content from a German newspaper. And finally, we will show annotations of historic maps of Rome from the National Gallery of Art, and the annotations are used to tag areas within maps. Here we've embedded Tamerlane into a static web page This is a prototype of the Doomsday Book for a single chapter, Lincolnshire. And we're able to search annotations from the book in both Latin and English. We can display the metadata for a collection or a manifest, and we can switch from images to a manifest. We only have one manifest in this example. For multiple manifests, another way to navigate would be to use search. We have the traditional features, zoom, and you can go full screen. The annotations are in English now. We've switched to Latin. Now we're going to do a search for a term in Latin using the keyword completion. We're searching for eels. I'm going to jump into the section that mentions eels. So it's in Latin, but we can switch to English, and we can read that there were 200 eels there. We can copy that data and then reference it from the annotation URI, so we could cite that in academic literature. This example is taken from the IIIF cookbook recipes, and it's a nice example showing a collection that has OCR content from newspaper articles. If we want to search this, we need to provide a back-end search service. So we're using AnaSearch, which is available on our National Archives GitHub repository. That provides the endpoints for the annotation search and the auto-completion of keywords. Again, we can switch in here to the collection view and manifest view of metadata. This time, if we switch to manifests, there's two different manifests available. We can do zoom as before. Annotations are in German. Here it's showing that was detected as being German. So we're going to search for a chemist, apotheker, as a single result. And we jump right into the exact part of the newspaper that mentions that. The final example is going to use work by Matt Westerby from the National Gallery of Art. I think this is a really good example of searching historic maps that have been tagged or annotated. We've taken the existing collection that Matt has produced and then we've wrapped it in our own collection and added search endpoints and indexed it from that point. Again, we can look in the viewer at the collection and can see that the metadata is saying it's a wrapped collection. Each map is actually represented within a manifest, so there's 11 maps. And a great detail for zooming here. But we're going to try to look for hospitals within the range of maps that we have. And we're able to zoom right into the first hit. And similarly, we can zoom in and out of the second hit. In terms of future work, it'd be great to be able to support different levels of search of annotations. So this would enable searching, for example, the marginalia in our collections separately from the actual content or the main content. And this would be easy to implement because the content search provides a way to search on specific motivations. So it's just a question of adapting the UI to handle that in the best way, and also handling how to improve accessibility of the overall experience of the viewer. With presentation 4 coming out, there's some interesting features there that we need to look at implementing, and this will require work on the parser that supports both AnaSearch and Tamerlane called Manifest. Thank you very much for listening. I'll paste links to the demos that I've shown in the chat if you'd like to experiment with them.
Okay, thanks, John. Up next, a presentation from Glen Robson.
Welcome to the Advancing IIIF and Python presentation, where we're going to share the latest IIIF Prezi 3 developments. IIIF Prezi is an organization on GitHub which has two projects, IIIF Prezi and IIIF Prezi 3. IIIF Prezi supports IIIF version 2 and is not currently maintained. IIIF Prezi 3 supports IIIF version 3 and is the one we're going to talk about today. From now on, if I mention IIIF Prezi, I'm talking about the IIIF Prezi 3 library. Another project that might be of interest if you do have to work with version 2 manifests is a Prezi 2 to 3 converter, which will upgrade a version 2 manifest to a version 3 so that it can be used with IIIF Prezi 3. All of these projects are written in Python and help with creating and editing IIIF manifests and annotations. IIIF Prezi 3 uses an unusual methodology in that the main Python code is automatically generated from a JSON schema. The JSON schema powers a IIIF presentation validator and was developed independently of IIIF Prezi. We use something called Data Model Code Generator to convert from the schema to Python code. This works with a package called Pydantic that ensures that any manifest produced by IIIF Prezi is a valid IIIF. This has some advantages, but we found it can also create code that is difficult to use. So the main work on the IIIF Prezi application is to add helpers to make the common tasks easier. IIIF Prezi is also linked to the IIIF cookbook. And if you look at a recipe, you will see a link to the IIIF Prezi documentation showing you how to implement it in code. The example on the right is for creating a simple image manifest. An added bonus is that while working with IIIF Prezi, we found issues with the schema which are now fixed and benefits both IIIF Prezi and also the IIIF validator. I mentioned generating code from the schema can mean the code is hard to use, and this is no more obvious than the names the code generator chose for IIIF classes. For example, can anyone guess what service item 1 means? Obviously, it's a IIIF version 2 image service. In the latest version, we have edited the schema to add a title for each class, which means better names appear in IIIF Prezi. So service item is now renamed service version 3 or service version 2. The code generator had difficulty naming lists of things compared to the thing itself. So often you would get homepage for the list of home pages and homepage item for the individual one. Now you get homepages for the list and homepage for an item. Finally, the selectors were a bit of a nightmare, but now they're named as you'd expect. I'll pass on to Mark now to talk through the other big changes we have in version 3.1 of IIIF Prezi 3.
Thanks, Glenn. Over the years, a common problem for IIIF Prezi coming from our underlying schema and our generated classes was lack of support for web annotations. As Glenn mentioned earlier, this code base is largely generated from the schema in the IIIF presentation validator. Historically, the rules in the schema were very specific and primarily written to ensure that recipes in the IIIF cookbook passed validation. This did not necessarily mean that the way it was implemented in the JSON schema was consistent with what was stated in the ontology. On the right here, you can see what the rules for an annotation were just a few months ago and how different it is from what you might find in the W3C web annotations model. This caused problems for developers who were using the library when they'd want to do something that had never been done before in the IIIF cookbook. To fix this problem and to allow developers to use the library in any valid way they could imagine, we decided to replace what was in the underlying JSON schema with rules directly from the upstream ontology. This ensures our annotation class should identically match what is coming from the W3C web annotations model. By doing this, developers can now do what they want and ensure that it is fully valid. The biggest request we've had in recent months was to upgrade Pydantic to Pydantic 2. If you've ever written any Python, you probably run into a situation where pip returns a giant block of red text telling you that two of your libraries are fighting over the same dependency. Until recently, this was a problem with IIIF Prezi and Pydantic. The version we've been using is very old, and libraries had abandoned it for the latest version of Pydantic for performance reasons. This made it extremely difficult to use IIIF Prezi with a modern Python library. To fix this, we have replaced Pydantic 1 with Pydantic 2. So if you have a project that needs to use a popular library like FastAPI, Google Gemini, or LangChain, IIIF Prezi should now be seamless to install. So you might be struggling to see what these new features mean for IIIF Prezi, so I wanted to share a quick example of what these features allow that wouldn't be possible previously. The code on the left is from a tool called IIIF Paleography that transcribes handwritten text in IIIF manifest using Google Gemini. Before the recent changes, this would have been impossible because the Google Gemini library required Pydantic 2, and you would lose these optional annotation properties like purpose, creator, and created due to how that output was validated. To wrap things up, I want to emphasize that IIIF Prezi 3 is more than just a library, it's a community-driven project. This tool is fully built by volunteers who serve the entire IIIF Python community. If you want to join us, we'd love to have you. GitHub is where we track our bugs, issues, and our future roadmap. We meet face-to-face once a month in our community calls that are held on Wednesdays, the second Wednesday of each month at 4 p.m. UTC. In these calls, we discuss issues, needs, and develop milestones. If you have a quick how-to question or just want to troubleshoot an idea, feel free to join the IIIF Prezi 3 channel in IIIF Slack. And finally, we'd love to hear about what you are building. We often hear about needs for the library, but aren't often aware of how it's being used. Thanks very much.
Thanks, Glenn and Mark. Up next, a presentation from Nuno Freire.
Hello, I am Nuno Freire, a researcher at Europeana, and I'm going to talk about delivering metadata to Europeana via the IIIF Change Discovery API. I'll start by introducing some context information about Europeana and the role of IIIF Change Discovery in aggregation for Europeana. Europeana maintains a central repository of metadata that is harvested mainly via the OAI-PMH protocol. The aggregation model of Europeana is based on a metadata model designed for data interoperability in the GLEM sector. This format is called Europeana Data Model, or simply EDM. It is an RDF-based data model developed as a community effort under the coordination of Europeana. For a few years, Europeana has been experimenting with new approaches to innovate its aggregation model and technology. Two alternative technologies have been recently piloted successfully. One is linked data, and the other one is IIIF Change Discovery, the topic of this talk. IIIF Change Discovery provides similar functionality to OAI-PMH, but it is focused on the IIIF resources. It allows providers to describe changes to IIIF resources and provides the location of those resources. For aggregation by Europeana, access to structured metadata is also required. So while change discovery does not directly provide the metadata, it can be obtained via the IIIF manifests that are pointed to by the API. In 2025, the Europeana Foundation and the Czech Olympic Committee collaborated on an aggregation pilot that tested the implementation of metadata exchange using IIIF Change Discovery. In recent years, the Czech Olympic Committee has begun making its collections of sports heritage materials available via IIIF. To further increase their visibility and accessibility, it decided to share these collections through Europeana as well. IIIF Change Discovery offered a standardized way for them to do so. The pilot aggregated the photography dataset provided by the Czech Olympic Committee. The Czech Olympic Committee implemented a IIIF change discovery endpoint and included in its manifests links to EDM metadata about the images. On the other side, a IIIF change discovery client was implemented by the Europeana, who harvested the dataset and ingested it in Europeana's production system. Here we can see an example of the output of the change discovery endpoint. The slide highlights how the creation of a IIIF manifest is represented by an activity streams activity. Here we see a IIIF manifest containing in the See Also section the link to the EDM record that is required by Europeana. Information that the link in the See Also leads to EDM is provided in the field profile, which contains the value of the EDM namespace. The images are now accessible via the Europeana website. This pilot confirmed that IIIF change discovery is a viable method for providing datasets to Europeana. The API is now supported by Metis, the ingestion system of Europeana, so any data partner can use this approach to deliver collections. Next, Europeana Foundation will integrate its IIIF change discovery client into the Metis sandbox, a workspace for partners to test their datasets. This will enable partners to test their own implementations of IIIF change discovery and submit them for publication into the Europeana website. If you have any collections published using IIIF and would like to experiment with IIIF change discovery to have them harvested into Europeana, please contact us. Thank you for your attention. I'll leave you with my email if you wish to contact us in the future.
Okay, thanks, Nuno. Up next, we have a presentation from Thomas Howert and Mario van Bassen.
Anchoring authorship in IIIF.
Hello, I'm Thomas. Thanks for having us. It's a great pleasure to be here with the IIIF community. Together with my colleague Mario, we'll present our solution approach to proof origin of digital content. We call it ledg.it. Proof, protect, preserve. In the IIIF world, we're not just publishing media, we're stewarding it across institutions and decades. What generative AI changed is scale and speed of manipulation. Synthetic and altered content is now easy to produce and hard to verify, which puts trust in collections under pressure. Metadata remains essential, but isn't proof. It can be edited, rewritten, or replaced. And after that, it's hard to tell what was original and what was added later. So the goal isn't to detect truth. The goal is durable proof of origin, provenance that stays verifiable as media is transformed, reused, and referenced over time. That's the layer we add, anchoring authorship, not defining truth. There is a pretty universal trust pattern, and it's especially visible in digital heritage. We look at the artifact, its context, and a way to verify it. That's why we frame this as content, context, confidence. Content means the authenticity signal stays in the media itself. So it survives what IIIF does every day: derivatives, resizing, recompression, rehosting. Context means provenance can't be silently rewritten later. So we anchor provenance claims to an open, tamper-evident record, interoperable and privacy-preserving by design. And confidence means verification is independent and usable by anyone, any institution, any toolchain, any viewer, fitting along standards rather than replacing them. Our goal is to contribute a clean optional interface the community can adopt. Our solution approach in 3 words: embed, anchor, verify. We embed an imperceptible watermark at creation or ingestion, designed to survive real-world transformations. Then we anchor a cryptographic commitment and a minimal provenance claim to a public, decentralized record, giving a timestamp, tamper-evident reference that doesn't depend on any single institution, platform, or vendor. Finally, anyone can extract the signal and verify it against that public record. Verification is portable, works across tool chains, and the core kernel is open source, so the community can audit it, integrate it, and keep it interoperable. The outcome is simple. Provenance stays checkable even after content has traveled. Our integration principle is quite simple. Don't change IIIF. Extend it with an optional interoperable service. When provenance is requested, ledg.it returns such a provenance-enabled derivative with an imperceptible watermark, together with an identifier that might be, for example, a stable pointer like the IIIF image ID. Because the response is deterministic for a given request, it stays cache-friendly. Repositories and CDNs can cache it in its ID like any other derivative. Later verification is straightforward. Verify by ID or by the delivered image, and you get a clear result plus a link to the anchored provenance record. The IIIF manifest remains where meaning lives. Descriptive metadata, rights, attribution, curated context. We don't duplicate that. Our proof layer stays minimal. It stores only what's needed for verification. Proof reference and identifiers. Nothing descriptive. To connect both worlds, we support two linking modes. Option A link via a stable identifier the institution controls, often the manifest URL or an internal ID. Option B, a link via a reproducible hash of the manifest, so anyone can recompute the digest from the same content and confirm integrity. Basically, the manifest remains the authoritative context, and provenance adds a verifiable proof link without moving any meaning out of IIIF. With that architecture in mind, Mario will now show the workflow live in the IIIF delivery pipeline.
Hi, I'm Mario. I'm a student at the Technical University of Vienna in the subject of visual computing, and at the moment I'm working at ledg.it in the software development team. And today I will outline for you our workflow concept for integrating imperceptible watermarking into an IIIF image delivery pipeline. The focus is not on a specific implementation or a particular watermarking method, but on the process logic and on where such a capability could fit into an existing IIIF mechanism. The starting point is the standard IIIF image request model with deterministic transformations, and in practice, protective measures like watermarking are often implemented outside this flow and therefore lack a uniform integrated interface at the IIIF level. The central idea in this demo is to treat watermarking as an optional delivery variant. Clients can request either an unmodified retention or a provenance-enabled retention, while the underlying source image remain unchanged. The on-the-fly at delivery time placement is motivated by robustness considerations. Watermarking is applied to the final exported or distributed asset rather than to intermediate representations that are still subject to editing operations. In other words, editing occurs first, watermarking is applied when a retention is generated for dissemination. A second aspect is verification. Alongside the ability to request a provenance-enabled retention, the workflow includes a discoverable verification endpoint, enabling third parties to check whether a given delivered retention contains the provenance signal and to obtain an identifier and confidential measure. From a standardization perspective, the goal would be to define an IIIF compatible interface for first requesting provenance-enabled retentions and second discovering a verification service without standardization the watermarking algorithm itself. This would allow at the end optional watermarking and subsequent verification to be integrated into IIIF-based delivery environments without requiring systematic modification of existing image repositories.
Thank you again for having us. If this resonates, we'd love to collaborate on a draft extension and a reference implementation. Feel free to contact us anytime. Bye-bye.
Okay, thank you, Thomas and Mario. And our final lightning talk for today Alexis Pantos will be presenting.
We want to Hi and greetings from Norway. Today we want to take you through our current systems and talk a bit where we see overlaps with IIIF. It is very much a work in progress, and we've used this lightning talk as a bit of a deadline to get ourselves moving. We're from the Museum of Cultural History. It's part of the University of Oslo, and we're a research museum, but also have two main public-facing outlets, the Historical Museum in the centre and the Museum of the Viking Age, which is under redevelopment. The museum has been collecting 3D data for well over a decade now, from using technologies such as structured light scanning, photogrammetry, CT scanning. Our primary outlet for the 3D data is the self-hosted instance of the Bitfrost platform. It's based on Lund's dynamic collections. We don't currently have any 2D IIIF servers, but this is something that we're wanting to change in the future as well. Bitfrost is based on 3D Hop, which has many strengths, but it doesn't support PBR rendering, complex lighting, animations, or multiple textures. So as a result, we are currently manually publishing the same models with information through different channels, different platforms such as Sketchfab and Google Model Viewer, so that we can meet the different audience needs. The USP of 3D Hop is perhaps the streaming Nexus file model format, which means we can serve large models in the region of tens of millions of polygons with fast first point loading times and without complex optimization pipelines in the data prep. The current system supports multi-part model viewing, meaning we can handle complex objects which are scanned separately but should live together. And the viewer supports many basic camera parameters and permits translation, rotation, scaling of individual model elements, as well as world orientations. But transformations do need to be provided in a matrix suitable for the underlying Spider GL. The system has got an annotation capability, so you can save views, you can save spots. These are exported as JSON formatted text files without the need for any user login, and they can be shared easily, and other users can load these through their own browser if they want to. And we use this in teaching, where a lecturer in classical archaeology can give tasks to the students. They can fill out the notes and send them for marking later. Bitfrost is specifically designed for objects, but we also work with other scales of 3D data with the excavations that we work on. So these are landscape scale, we've got geographic coordinates, we've got multiple objects, multiple sizes. We handle the geographic coordinates with a simple offset at the moment, and we'd like to find a home for that in the manifest. But we're also looking to re-situ objects, which are maybe documented back in the lab after the excavation, either micro-excavations or reconstructions, and put them back into their original location for the researchers to look at. At the moment, we need to handle this separately, but ideally we would be able to pull these more directly from a central repository and handle everything through the manifests and different offsets. Support OBJ and PLY, both with conversion and rendering. But there are some challenges if we're wanting to convert things to Nexus only scenes if these models are already optimized. It's worth mentioning that 3D Hop is still being developed, and there's plans for a GLB converter as well as moving the engine to 3JS. From our side, we're working on a React component with vanilla JavaScript as well to ingest IIIF manifests into 3D Hop, with a parent component that will load NXZ files into 3D Hop and other formats into other viewers. And we also plan to generate our own manifest on the fly from Postgres views, feeding a RESTful API endpoint.
Okay, thank you to all of our presenters. I will try and catch up on the chat and see if we have any questions in there. Maybe while I'm doing that, if there's anyone who wants to start off with questions by raising their hand, that would be excellent. Yeah, Ron.
Thanks. I hope you can hear me okay. I'm on out and about Wi-Fi. If it's okay, start with the last one. It's really good to see what you're doing, Alexis, and love to talk more. I'm one of the co-chairs of the technical spec for the API 4.0, Triple 3D. And indeed, Federico, 3D Hop Nexus, has been part of those discussions early on. So maybe we can have some coming together. But it'd be helpful to know, are you looking also for the capabilities to recreate scenes? It sounded like that. Could you say a little bit more about the recontextualization I think you had in mind? Is Alexis here?
I believe so.
Or anyone?
Howert is part of this team, and he just said, sounds great, Ronald.
Okay, so maybe we can catch up another time. That'd be great. Oh, having mic issues. Got it.
Yeah.
Happy to catch up, and please come to one of our Triple 3D meetings, community or tech spec. That'd be great.
Okay, other questions? It looks like most of what was asked in the chat has been answered on the fly by the presenters. Yeah.
I'll jump in again. Thanks. John Moore, I was glad you mentioned interest in 4.0. Do you have some things in mind? Because part of what you were showing is one of those instances we hope to connect more with the map group so that 3D and topology and et cetera come together. Is that part of what you're looking at, the kind of search into depth as well as breadth?
Hi, Ronald. Actually, it was mostly focused around annotation and the extra support there. There were some quick wins like motivation for being able to click on the annotation and open the link. There's a few things like that, but I think the main one I was going to look at was the being able to have a collection of manifests and being able to page those in the UI for very large collections. So there's sort of functional things there that I was looking at, not 3D. I'm not the person to ask about 3D.
I apologize. I always try to get that in, but no, there are other important cases for 4.0, which is you're saying. But it looks really good. Thanks.
So I see one question in the chat for the ledg.it group, which is basically, does it have some sort of private public key infrastructure where the watermark can be verified against some authority's published identity? How do you prevent someone from faking a watermark? There, Thomas or Mario? There's Mario. Okay.
Yeah, and now we're both together. Sorry, the question once again, to be 100% sure.
It's from Ranja. Does it have some kind of public-private key infrastructure where the watermark can be verified against some authority's published identity?
Yeah, basically this is meant as a decentralized framework
So everyone can participate and run their own node, and all nodes share one global verifier, which is public. So basically, it's some kind of, and so you have some kind of the private key by yourself, by your ID with your authorized against the system. The public key is within the watermark. So it's the information, the unique ID is embedded within the watermark, and you can globally verify it without being participant in the system.
Okay, so do you have like you said, you have like the global something that handles all the verification for everyone who participates in this scheme. So for this to be durable, what happens if that infrastructure just goes away? The whatever.
That's basically the problem with every open infrastructure that you want to achieve, right? For sure, this needs some kind of adoption or some tipping point to be accepted globally. But if this would be in some point achieved, then it could be self-sustaining. So this is exactly why why it's meant to be a decentralized open source system, and that's not some vendor locked-in Stegon watermarking implementation. But it should be an open standard which should be interoperable, so which every other standards could integrate, right? That's the base idea.
Yeah, that makes me think of PGP keys.
You
have your own private key. You publish.
The base principles that it's designed with are very cypherpunk, right? So it's very cryptographic, very privacy by design, very decentralized, governance driven, and not. I think this is especially what the digital heritage and the archive community is looking for, right? Something that is not like an open standard somehow, right?
Yeah, makes sense. Basically, you sign an image with your key, and you have it. You have the signature in band with the pixel data. Okay.
And everybody, as it's an open standard, everybody can extract that signature and verify it against that public ledger, basically, right? And we're totally open on which kind of distributed ledger in the end the information stays. It's just we want to be like a middleware between the content and some kind of security.
Okay, sounds good. Thank you.
Other questions?
Maybe just another, if I may, for for Nuno. It was great to hear what's been going on with the European data model and the Czech work. Do you have some other things in the pipelines in terms of the IIIF expansion in Europeana world? Sorry, maybe an awkward question. Don't mean it that way.
Yeah, it's well, there's currently a lot going on about INIDM for making 3D available in INIDM, and currently we are actually working on how to represent that or how to make that available in the IIIF version 3 manifest. So, and looking forward to actually be able to do it properly in version 4. But now, so we are currently trying to make 3D models available for download, just showing as a rendering option on the manifest so that they can be downloaded, but not yet visualized. Then besides that, I don't think there's any particular point that I would like to mention at this point. Yeah.
No, thanks very much. And I know you and Glen work closely together, and happy to follow up as and when, particularly in 3D. And sorry for the background sounds where I am. Thanks for muting me, Caitlin.
Okay, and then this for the ledg.it team. Could you share some links, public documentation to the watermarking work you've done? I don't know if that's up earlier in the chat.
Thomas, are you there? Okay, as long we are waiting for Thomas, then I just answer him. Yeah, the thing is, we are still in the, as Thomas already said, or we already talked about, there is this one global ID, for example, which identifies the watermarking in a whole. And at the moment, we were here mainly to present how a watermark in itself could be supported by IIIF or built in. And exactly watermarking we are still in building up. That means our main challenge, as everybody knows, it's hard to get big information into a small image. And we are about creating our individual pointing. I just throw some words inside, pointer and stuff like that we can put this global or unit ID into it. But I can give it to you, Thomas, if you want to add some.
Yeah, I think this is the ice Mario didn't want to step on. We had the solution already built on TRL6. Due to some strategic disalignments with the prior tech team regarding the open sourceness and the decentralization of everything, we are currently building everything from scratch. I have started rebuilding in some kind of way, but are close to regaining this, because basically we're not reinventing the wheel. What we are just using are different kind of already existing open frameworks, especially in the open watermark codex. And then it's basically more a kind of re-engineering and especially the decentralization of it. So we have been, so the watermark technology by itself is very proven. The anchoring within distributed ledger system is existing in millions per block, or within 10 minutes since 2017. So basically, we're just building it together and want to make it accessible for everybody. So basically, we have nothing, no Git to show you, but we come back in summer maybe with a concrete implementation. And what Mario was showing was a rapid prototype, basically, and showed that it's agnostic from any context. The main challenge within the system is what Mario described as the unique ID, because the watermark by itself shouldn't be every watermark has to be unique within the framework in the system. That's the basic challenge, but it's basically just a standard IT problem. As Ronald knows. No, you can build with multiple public informations before, and you can reach up to a quadrillion images that could be unique within the system, and I think this should be enough for at least some amount of time.
Let me just jump in with a quick follow-up with an interest in having families of content reconnecting. It might be interesting to do the sort of ARC ID approach of sort of the ability to have families marked in a way that indicates they are connected.
Yeah, but basically what Mario showed would be like a very simple implementation within IIIF, right? That every derivative gets its own derivative. But basically you could also work with like a mother-child concept within the derivatives, right? So you don't have to regenerate the image or the unique ID every time, but it's mostly certain frames of the image are cropped. You could reuse these watermarks again, but this would be a more sophisticated implementation. I calculated around 50 to 60 days. I already know what the effort would be, I guess. But this is also like something that came into our mind. But today we wanted to show just the principle and see if this fits for the whole community, and if yes, we will continue working on it.
And Thomas, there was also a question from Ronja in the chat.
Okay.
But I can also try to answer it. Yes, I just say Ronja, or you're completely right. That's one of the biggest challenges, actually. The thing is, for IIIF and of course, from the API, there's a lot of transformation. We had at the moment just the idea not putting on the watermarking, then transform it, just turn it around, transform it, and then watermark it. But you're totally right. At the end, to have a solution to fit everything of distortion, rotation, that we think a part of the problem, because at the end you have many paths maybe at the to go, and then you say, okay, you want to have an image which can be defeated against rotation or against brightening or stuff like that. Because to have one formula or one generation model or stuff like that to fit every attack is pretty optimistic, we think. And even to have the original as source as it is would be a great advantage, actually, we think.
We even think there is an advantage if the content journey is not totally survived, because if you're still owner of the digital file, you can somehow claim that it was watermarked by yourself. You have a more advantage against strict metadata, as we can see be in the front of the courts. The other aspect is we have to be honest, there is no one size fits it all solution in watermarking, but even a 90% solution might be better, especially as you can identify the weak watermarks before giving out the watermark image. Because you can, with extraction, you can double check how good the watermark actually works before handing it out to the user.
Any more questions?
Okay, well, I do want to thank the Ledg.it team for bringing up this issue. I think it's really been a fascinating discussion, and I think the whole question of authenticity in digital everything these days is a really important topic. I know it's being explored in a lot of different venues, and I think it's really great that you're looking at it with a IIIF eye to the problem. So I think we may be hearing more about that within the IIIF community from you in the coming year. I'd also like to thank everyone who's attended over the past 3 days in whatever time zone you've been. We had a really good turnout. I think the January timeframe for the online meeting is really the successful timeframe. It's the beginning of the year. You're coming back after the holiday season and fresh and ready to talk IIIF. So probably look forward to the online again next January. And yet we also do have the annual meeting coming up, which Caitlin will tell a little bit about it in her closing remarks. So again, thanks everyone. Thanks to Glen for his help with the logistics, and a big round of applause for Caitlin, who did all the amazing logistics of managing emails, schedules, everything, and getting this all together. So thanks, Caitlin, for all of your work in keeping everyone on track, on time for the last few days. And with that, I'll turn it back to Caitlin for closing remarks.
Thanks, Martin. So before I let you all go back to your day jobs after we've taken your attention for the better part of a week, just a few things I'd like to leave you with. One is, if this is the first IIIF meeting you've attended, or if you are not a regular attendee of our events, I would encourage you to get involved. On our website is our community calendar, and all of our events, our community groups, our technical groups, our monthly community calls are all on there. A lot of the work that was either done in workshops or presentations this week came out of our community groups. I think we heard from 3D, education, accessibility, AV, interactive 2D. There's lots of good work going on in there. And if anything you heard this week resonated with you, I would encourage you to go to the calendar, find something that you like, and just jump in. Everything there is open to all. If you saw me cringing a little bit about the meeting being in January, it's because the same time that we are doing this, we are in the throes of planning our in-person meeting. So this year we will be in the Netherlands, June 1st through 4th. It's a great opportunity to learn more about IIIF, demo things that you're working on, and to connect with the wider community. Look out for registration for this happening in February, and I mentioned at the beginning of the week that we are offering 2 travel scholarships. So if this is something you haven't attended and you don't know if you will have internal funding, I would encourage you to look on the website for the travel scholarship and submit an application. And then the best way to hear about these things outside of our calls is to get involved either by joining a call, as we said on the community calendar, subscribing to the newsletter, or joining us on Slack. The Slack is a great place to ask questions, look for demos, get examples, troubleshoot. There's nearly 3,000 people in there, and there's a huge community that is looking to help. So with that, I will send you back into regular work, or for those who are in a later time zone, maybe to bed. And thank you all for joining us. Bye now.